Okay, so the second barrier that we are going to talk about is the blood-brain barrier. And this is the most famous out of all the barriers. So, 2. The blood-brain barrier. Okay. So what does this one look like? So this is when we've got capillaries coming into the actual brain tissue. All right. So we are going to draw ourselves a cutaway section of the capillary. Okay. So I'm going to give myself a little more room above it. Okay, so like that. All right. So this is our blood vessel. Inside our blood vessel, we've got red blood cells floating around. Okay. So inside here, this is where the blood is. Okay. The walls of the capillary are lined with a type of cell called endothelial cells. Okay, so they look a bit like this. Okay. All right. Then, also in the walls of these vessels, these blood vessels, we've got pericytes. Not parasites, but pericytes. Okay. Should have drawn this from the inside out. So, we've got blood. And these are the red blood cells. Okay. And so this in here is all blood. Right, this is the fluid inside of your blood cells. Okay, then we've got little cells that sit right here. Oh, I'm not going to use black. Purple. We've got little cells that sit right along here, along the outside of the endothelial cells. Okay. Okay. And then, okay, so let's label some things. Actually, okay, then we have more glia limitans, which if you remember from last time, those are the feet of astrocytes. Okay, so then we've got surrounding all of this are glial cells. Okay. Okay, so let's label things. What do I want to use? I guess I'll just use black. So these green cells, this is the glia limitans. This is just a fancy word for astrocytic feet. Okay? So it's the very end of a process that comes out of the glial cell astrocytes. All right? Then these purple cells, this is a type of cell called a parasite. So not a parasite, like, a small creature that sucks off of another creature in order to live. This is a type of cell, a pericyte. Okay? Then these, so yeah, these are all the same. And then these two are called endothelial cells. Okay, and then these are red blood cells. Okay, this is the inside of the vessel, the capillary rather, and all of this surrounding area okay, this is all brain tissue. Can't really see the green if I remember correctly, so I'll just label it in black. Out here is brain tissue. Okay? So, the barrier is actually a barrier around each and every capillary that comes into the brain. Okay? So that is the blood-brain barrier. It technically is spread out across the brain. Wherever there is a capillary, wherever there's a blood vessel coming into the brain tissue. So, what this actually means is that the blood-brain barrier is basically the cerebral vasculature. Cerebral vasculature. Okay. Vasculature just means a network, a system of blood vessels and capillaries. Okay, so it's like a web of blood pathways. Okay, so all of the blood pathways that go into the brain tissue, the cerebral vasculature, that is the blood-brain barrier. All right, so this barrier is created by what is called tight junctions. Tight junctions. And we'll underline this word. Tight junctions between endothelial cells. Okay, so these guys here. Okay, endothelial cells of the capillaries in the central nervous system. Okay, so these guys, the endothelial cells, they're actually, they have what are called tight junctions. Okay, so their membranes are really tightly connected to each other so that they create a nice barrier, so that nothing can pass through. So let's define some words. Let's start with endothelial cell. Okay. And these are just the cells that make up the blood vessel walls. So, create blood vessel walls. Okay. Then the next new word that we have here was pericyte. So what is this strange little cell? So these are cells that wrap around the endothelial cells, and they regulate blood flow through the blood vessel, and also they regulate what passes in and out of the blood vessel. Okay, so basically the pericytes are the ones who control the blood-brain barrier. They control what passes from the bloodstream into brain tissue and what passes from brain tissue into the bloodstream, okay? So pericytes are cells wrapped around the endothelial cells, which I'm going to abbreviate right now as EC, the endothelial cells, okay? And they regulate blood flow and the permeability. So this is permeability. That's just a fancy word that means how easy is it for things to pass through, what can or cannot pass through, okay? So the permeability of the blood-brain barrier, okay? All right, so when they're controlling the permeability, it's not just, molecules like chemicals, hormones, neurotransmitters, oxygen, water, so lots of small molecules, or entire cells could pass through the vessel wall. And the thing that decides what gets to pass is the pericyte. Okay? And then we already learned about the glia limitans, the astrocytic feet, and they wrap around and support the endothelial cells. Okay, so this barrier separates circulating blood from the extracellular fluid surrounding central nervous system cells. So this area, this where I labeled brain tissue, so that's not just cells, but also the space in between them. Okay? So this makes sure that only the things we want from the bloodstream come out and nothing else. And we make sure only the things that need to go into the bloodstream from the brain get in. Okay? Usually, the stuff that is allowed to pass through is, so usually, hydrophobic. So this means molecules that hate water. Phobic is you dislike it. Hydro is water. Hydrophobic and small molecules are generally allowed to diffuse out of the capillaries into the brain tissues. So these are allowed. Okay? And then the molecules that love water, hydrophilic and or large molecules plus bacteria, those are not allowed. And they are kept out. Okay? So that's what the blood-brain barrier looks like, and that's what it does. It makes sure only the good things pass into the brain tissue, and it keeps out large molecules, hydrophilic molecules, and bacteria, okay? All right, so that's the blood-brain barrier. Our next barrier, moving right along. Okay, so our next barrier is the CSF brain barrier. CSF brain barrier. Okay, so this is the barrier between the brain tissue and the vasculatory system that runs through the middle of the brain. So this barrier is created by a cell we are now very familiar with, the glial cell ependymocytes or ependymal cells, created by ependymocytes, okay? Between brain tissue, sorry, this looks confusing. Between brain tissue and the ventricular system. Okay? So let's draw what this looks like. Oh, real quick note about ependymocytes, which we didn't get to last time, but it's relevant here. So while studying the ependymocytes in the CSF brain barrier, it was discovered that ependymocytes can act as reservoir cells, which is kind of like stem cells. So stem cells are cells that can constantly renew. They're kind of like immortal in a way. They can turn into all kinds of cells, usually. So a reservoir cell is very similar, but not quite the same. Okay, so these can serve as reservoir cells. And what this means is they can help grow new neurons. But they're not quite stem cells because they can't actually renew themselves and they can only make a limited number of new neurons. So we're going to say not stem cells because they don't self-renew and they can grow new neurons a limited number of times. So they can't do it forever. It's not like they can keep making new cells forever and ever and ever. There's a limit, but they can help grow new neurons. And generally where it happens is here, right next to the ventricular system. Okay, so let's draw this barrier. So we've got our ependymocytes. Ependymocytes. All right. So remember how ependymocytes look? They look like boxes with like long hair on one side and like short little tentacles on the other. Okay? So they kind of look like this. And they've got like little things down there. Okay. All right. And on this side is the cerebral spinal fluid, okay? So we've got all the fluid out here. And then on this other side, we have brain tissue. And guess what? Other glial cell is part of this barrier. Hint is they've been involved in a lot of the barriers, and they're not the ependymocytes. Okay, the ones that I'm thinking of are the astrocytes. So we got more astrocytic feet. Okay, so over here is the brain tissue. And we've got the astrocytic feet. All right. So these are astrocytes. And these are ependymal cells. And in a developing brain, okay, so if we say in a developing brain, and this is usually up until age like 18 to 24, okay? So you are still a developing brain. Once you are finished with puberty, then you're considered an adult brain. But until you finish puberty, you are considered a developing brain. And in a developing brain, this barrier, the ependymal cells are really tight next to each other. So nothing from the CSF, it cannot pass through, all right? However, in an adult brain, what happens is the ependymocytes they spread out a bit, okay? And they're less tightly packed next to each other. So their cell membranes, it's just a tiny bit of space, but what this means is in an adult brain, this barrier, the CSF brain barrier, is more permeable. So things from the CSF are allowed to pass through more easily, okay? All right, so that's it for the CSF brain barrier. So let's go on to our last barrier, the blood CSF barrier. Okay, this is a good time to pause, finish taking notes, finish your drawings, and now I'm going to erase it. All right, the very last barrier is our blood CSF barrier. Okay, now this is found in a very special structure in the brain that is called the choroid plexus. So this is called the choroid plexus. Okay? Okay, so the choroid plexus, it separates blood from CSF, and it also, part of it separates the CSF from the brain tissue. So part of it also makes the CSF brain barrier. So the choroid plexus is actually a little bit of both of these, and it restricts the passage of stuff from the brain, from blood into the brain, okay? So, what does this barrier do? It is, generally speaking, the closest connection to the immune system, okay? So, this barrier, it controls the entry of leukocytes. Okay, that is a type of immune system cell, and other immune system cells into the brain. Okay, so this barrier works very closely with the microglia. Remember the microglia? The microglia are tiny little glia that can change shape. They move all throughout the nervous system, and what they do is they monitor all parts of the nervous system for damage, for pain, for inflammation. And if any of those three are there, damage, pain, inflammation, they come back to the choroid plexus and they make sure the cells here know there needs to be more immune response in the brain, okay? This is also the barrier specifically that produces CSF. So it, I'll just write it instead of a bullet point. Okay, so it also produces the cerebral spinal fluid, and it also produces and releases into the brain. So it secretes a chemical called transferrin. Okay. Which is a blood protein. Oh, I should do this in purple. Okay, so this is a blood protein, and it controls the level of free iron in biological fluids. All right, so there's a lot of iron in your blood, and so transferrin controls how much iron is in the fluids that, well, basically in all fluids, not just blood, but also in CSF, in plasma. Plasma is the fluid that is in your blood, okay? So it is a blood protein that controls the levels of iron in biological fluids. Okay. Ooh. So let's draw this. All right. So the choroid plexus is inside, very deep inside of the brain, and it almost looks like a flower with like just many petals going off of it at once. So let's draw it. So guess which glial cell is involved. If this is if this barrier produces CSF, which glial cell produces CSF? Ependymocytes. Okay, so I'm going to make like a wiggly line here. Okay, and these are all the bottoms of ependymocytes. Okay. The main point is that they look very boxy, and the top has all these flagella-like wavy villi. Okay. All right. Okay. My cilia are starting to get quite fat. Okay, so, that was a lot. So these are ependymocytes, okay? And on the outside of them is the CSF. So all this out here, this is all the CSF, the cerebrospinal fluid. And on the inside, we have some blood vessels. And what makes the lining of blood vessels, do you remember? They're called endothelial cells, okay? So the blood vessel is also going to go along in the same shape, and these are all endothelial cells. Okay. Okay, so this is where the blood is. Okay, and each one of these endothelial cells, they've got a nucleus. Okay. Okay, lovely. And then we also have here another cell we've seen before, the pericytes. Okay, they are once again, they're helping regulate the flow of blood, the flow of nutrients, chemicals, and they decide how permeable is this barrier, okay? All right, so I think that's it. Okay, so let's just quickly label these. What's a color I haven't used? It's orange. Okay, so the green is the ependymal cells. Okay. The purple are the pericytes. Okay. And then the red, here we go. These are endothelial cells. Okay? All right, so those are the 4 blood, brain, and CSF barriers. And the last thing we are going to talk about is the neuromuscular junction, the connection between the nervous system and the muscles.